Agent skills can tell an agent what to do, but they don't automatically remember what happened the last time that skill ran in a real environment. That's what Hark adds: execution memory. Here, Hark is investigating a query regression. It begins by loading the official CockroachDB statement fingerprint agent skill. Before acting, it searches prior execution experience. On this first investigation, there is no useful precedent. The agent then gathers real diagnostic evidence from CockroachDB. A restricted database identity reaches a cluster setting check that the environment does not permit, and CockroachDB enforces that boundary. Hark doesn't escalate privileges or invent a result. It follows the safe diagnostic path using statement statistics, the query execution plan, and index metadata. From that evidence, the agent completes its diagnosis. But this is where Hark differs from an ordinary agent run. The failure, the recovery path, the successful actions, the diagnosis, and their provenance are retained as execution experience in CockroachDB. Now the incident is described differently. Before taking action, Hark searches its execution memory again. This time, it finds relevant precedent from the earlier run. That experience changes what happens next. The agent already knows the cluster setting preflight is a dead end in this environment, so it skips that path and goes directly to the useful diagnostic operations. It still gathers fresh evidence and produces a new, evidence-grounded diagnosis. The result is measurable. The first investigation used 4 tools and encountered 1 failure. The related investigation used 3 tools and encountered 0 failures. CockroachDB also records exactly where that experience came from and which later execution used it, so memory remains inspectable and can be invalidated without losing its audit history. Underneath, Hark runs its bounded agent runtime on AWS, follows agent skills, embeds execution experience, and uses CockroachDB distributed vector retrieval to bring relevant memory into future runs. Hark doesn't retrain the model, and it doesn't need to rewrite the skill. It carries forward what the agent learned from actually doing the work. Skills know the procedure. Hark remembers the work. Hark isn't tied to query regression. We used that workflow to validate the execution memory architecture end-to-end. To extend Hark, a workflow provides 4 things: its agent skill, workflow and environment scope, safe tools, and an adapter to the real environment. Everything underneath remains the same: execution evidence, experience memory, vector retrieval, failure recovery, provenance, and invalidation. Developers can follow the documented manual path or give the repository and workflow requirements to a coding agent, which can extend the existing production pattern. The workflow changes. Hark's memory plane stays the same.